Hello? Hi, can you hear me?
Hey, how's it going?
Good, how are you?
Good, pretty good.
Oh, you can hear me, right?
I can hear you. Yes.
Yeah, so thank you for taking your time to join the interview. I think this will be a good practice for both of us, so thanks. Yeah, so just a little bit about myself. Um, I'm fairly new to this platform. I've been in this for a couple of months now.
Uh-huh.
I joined this platform, I thought I wanted to improve my skills both as an interviewer and as an interviewee. So I thought this
Okay.
platform would be a good chance for me. So how long have you been prepping for these interviews? How long have you been in the platform?
On this platform for a couple of weeks, this is like my third or second, I can remember, interviewing. I'm basically get interviewed just to
Uh-huh.
practice and maybe I'm starting, just get started to looking for new jobs. So I guess this is a good chance for me to practice.
Yeah, yeah, definitely. Yeah. So yeah, we can dive right into the question, I believe. And
Okay.
I'm seeing that you'll be coding in C++.
Yep.
Okay, sure. So I'll copy the question right over.
Uh-huh.
All right, here is the
So,
question. Please just
mm-hmm.
take a look.
Okay. Okay. Giving a array of integers and
Mm-hmm.
returns the key most frequent elements.
Mm-hmm.
Okay, so the first example is we got 111, 223, 1 being the most frequent one, and the key is 2, so we want the second most frequent one, which is 2, so we return 1 and 2. Okay,
Yep.
straightforward enough. Okay, let me think. Um, so I guess kind of easy way to do this is I can loop through it, have a dictionary to count how many times it appears for each numbers in that array. And after
Uh-huh.
that, I can sort the counts and
Uh-huh.
just return the top key of them. Uh,
Yeah.
if I'm doing that, the time
Mm-hmm.
complexity will be basically the complexities for sorting them. So the worst scenario is going to be in log n. And if there's
Okay.
many duplicates, it might be lower than that, but
Uh-huh.
pretty much at that level.
Right.
Uh, but I guess that's kind of a little overkill since we don't really need to uh, sort everything because we
Right,
only
right,
want the
exactly.
most frequent one.
Exactly.
So let me think. Instead of sorting them, actually we can just grab the key most frequent one.
Mm-hmm.
We can do that by building a heap, I think.
Okay.
So if we build a maximal heap, use
Mm-hmm.
the count as
Mm-hmm.
value as the we will build the heap, and every
Uh-huh.
time we pop up the most frequent one and
Uh-huh.
reorganize the heap, and we do it k times. This way
Sure.
we can lower the time complexity to be just what like we build the heap. We building the heap is need like we actually don't need to build everything. We only need to keep the heap as big as k. So
Right.
time complexity gonna be n log k, something like that.
Yeah, sounds good.
So let's try some coding then.
Sure, let's
I
do it.
guess that's the best we can get. Am I right about that? I just want to make sure that's the right direction before I start coding.
No, that is the right direction. And yeah, let's
Okay.
dive right into coding. Yeah.
Sure. Okay. So let's have function that's return a list of integers.
Mm-hmm.
Let's just call it key most frequent, and it will take a list of integers as input, something like that. So that's gonna be our function.
Mm-hmm.
We got a list of input here. First thing I'm gonna do is I want to create a dictionary and count for each number that I'm seeing here. So ordered map int int. That's gonna be my count, and I'm gonna loop through everything here.
Mm-hmm.
And simple dot size. Okay. And const input I plus plus. Oops, doing that.
I think you're missing a bracket on line 29.
Oh yeah, that's why it's doing that. Thanks. Okay, so I got this. And I need a heap. C++ have priority queue for us to use.
Nice.
Inside of the priority queue, what do I want? So I'm gonna need the count, and I'm also gonna need the value. So why don't we just make it a pair?
Yep, sounds good.
So let's make it as a pair, and smallest. Let me see here if we want a min heap or we want a maximal heap. Actually, we just want a min heap. So every time we push something into the heap, we pop the less frequent one. So in the end, we got the most frequent on seeing the heap. So yeah, I just want a min heap. I just want a min heap, and the default behavior should be a min heap. So I don't need to do anything about that. Next thing I'm gonna do is I'm gonna loop everything in the dictionary. So in the dictionary, I'm gonna get current pair in my dictionary, which is counts. Counts here. So I got the counts. So the value gonna be this, and the count gonna be second. And so now I'm gonna actually do let's make a new pair here. Because I need to reverse first and second, so I'm gonna just do it this way. Make pair, use count as the first one, and value as the second one. So I didn't give the queue a name. I'm just gonna call it mean heap.
Okay.
So for my mean heap, I'm gonna push this into it. And if mean heap dot size is bigger than k, then I will pop something out of it. Okay. And so in the end, I'm gonna have a array or vector for my result. So let's loop through everything. Oh, I'm gonna just have a pair int current pair. Wait a second, not like that. Int I equals to this. And I want to make sure this is not empty in case that there's not enough number in it. And I also want to make sure this is smaller than k. If so, I plus plus. And so we have our pair is mean heap dot top, and the mean heap can then pop, and then we can put our number, which is the second of the pair, into our return value. Okay, and that seems to be it.
Yep, I think, yeah, that looks good. Could you reiterate the time complexities for this, please?
So the time complexity gonna be, so let's start from the beginning. So for the first for loop, it's gonna be big O of n being the number of value in that array. And for the second, it's gonna be a little less than big O of n. It's gonna be, I will just say big N of m being different number of different numbers. And at here, the third loop, so every time on the outside, we loop k times at most. So there's a k. And for the heap to pop up a value and reorganize, it takes log n of k. So it's gonna be log k here, since we got at most k. So the overall time complexity gonna be, I'll just write it here, gonna be whichever is bigger, either k log k or just n, something like that.
Yep, sounds good. So as an interviewer, I would be completely fine with this implementation. I think this works great. I think the time complexity is great. But since now we have quite a bit of time left and we have
Okay.
achieved this time complexity already, let's try to make it better. Can
Sure.
we do this in linear time?
Let me think about it. Do it in linear time. Duh, 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 duh. Well, if the input, the only thing I can think of on top of my head is if the input is kind of special, like if it's not bigger than a specific number, we can maybe use bucket sort, and that way we can lower it to like linear time.
Yeah, I think that's the right approach here because we have in the note it says that k is always valid, right? That means the input array will always have at most k unique freaking elements. So if you look at the example at line 18, for example, if number array is 112233, k cannot be 2 because there are no 2 unique most frequent elements, right? Because if k is 2, we have 3 numbers that share the same frequency, so k is not a valid number to be 2. So in this example, the only valid k it can have is 3.
Okay. I didn't. Thanks for pointing that out. I didn't really notice that at the beginning. So yeah, let me think about what you just said. So there's 3 different number with the same frequency. So the number k has to at least bigger than that.
Yes.
Okay. Okay, but wait a second. Is that related to what I'm saying? Like we can use bucket sort? I didn't quite see how those two are related.
Yeah, sure. So let's see. So if we look at the example on line 18, right? 112233, you see that each number has a frequency of 2, right?
Yep.
Now, if we can use the bucket to represent the frequency, the frequency of the numbers, can we do something? And I should clarify one thing. So in this example, right? The return value, the relative order of return value doesn't matter. What that means doesn't matter. What that means is this is equal to this.
Sure.
Or yeah. So the relative order doesn't matter.
Okay.
So if we can use the frequency as the bucket.
Sure. That way we can easily sort everything.
Yes.
I got you. So if we have some number and we can allocate another array,
exactly.
So something like that. So let me write a random. Let's just use the example from line 18. So I can basically allocate an array which has space of n at most.
Okay, sounds good.
And this one means with the frequency is 1, this one means frequency is 2, this means frequency is 3, so on and so forth. So that way we can easily use the bucket sort and do that thing. Okay, yeah, I got it.
Good.
Shall we try some code?
Sure, let's do it.
Okay. Let's see. Okay, most frequent. I will just call it 2 for simplicity. That's a
Sure.
bad naming convention, but for the interview papers, I will just use that.
Yeah, it's perfect.
Okay. So I got the vector. Oops. That's gonna be my bucket. And it will have a size of n. Wait a second. What should I be putting here? It shouldn't have a integer. It should have a vector of integer, because some of the number will have the same frequency.
Exactly.
Okay, I still kind of want to do the mapping stuff, which makes things a little easier here. Let me just copy it.
Sure.
So like this, we got the dictionary, we got the count. So next thing I'm gonna do, I'm just gonna copy this again. Got this for loop here. Okay, I got this for loop. And for this for loop, instead of putting them into the heap, I'm gonna use our bucket friend here. So that's gonna be second. That's our count, and I will push. Oops. I'll check the value, which is the first, like that. Well, I guess I don't have to keep counting where the most frequent one is, since I have to loop through it anyway. Yeah, I guess it doesn't really matter. I want to keep a variable here to count which one is the most frequent one, so we don't have to loop through from the very beginning or the very end. But I guess it doesn't really matter. We can just loop through everything. It still doesn't change anything.
Exactly.
So everything is in the bucket. Everything is in the bucket now. So let's write the last for loop here. I got the return value ready. And what I'm gonna do here. It's probably easier if I do count. Did I use a count already? Number needed equals to k, and for I equals to, I'm gonna go from the end of the bucket. And goes to this minus. So here, what do I got here? So if bucket I dot size not equal to 0, That means we have something in it.
Right.
And we just loop through it. J smaller than bucket I dot size J plus plus. So I'm gonna loop through everything in it and push it into our result here. So
Looks good.
Bucket I J J. Once I pushed it into numbers at -1, after we did that, if numbers, oh, I kind of want to do it in the beginning. If numbers needed already equals to 0, that means we got everything. Then we can break and return.
That looks good. Looks good. Just one minor.
Yep, actually, that's not the right position for the if statement. I just realized that. I might want to put it here.
Yeah, but we can. Yeah, that's correct. But we can assume that k is always right or always valid, so it will never be a time.
Right.
Yeah. But that's also fine. What you have put is perfectly fine. Yeah. One minor thing. Can we check the boundaries in line 71? I mean 37. Sorry, 37.
Sure. Let me think. Theoretically, we never hit a boundary, right?
Yeah, so if we have an input array of something like this, right? We have a bucket.
Oh, you're right. So I guess when I allocate the bucket, well, this actually need to be something like that because we never use 0. Nothing is 0.
Sure.
Yes, something like that.
Okay,
so something like that.
That looks good. Just please guide me through the context case, and I think we're good.
Okay, so like what we did before, the first loop, the first one is still big O of n linear time. The second is linear time instead of O n is O something like m. Different number of different number here. And in the end, we got here so it's still linear. It's linear of the size of the bucket, and the bucket is the same size as our input, so it's big O of n linear time.
Can you explain to me why this is still linear, even though we have two loops inside?
Okay. Yes, exactly. So even though we have two for loop here, the outside for loop seems like looping through everything. But let me see how to put that. So the second for loop, well, I'm trying to think if there's a worst case that this could be a little bit high.
Okay.
So for that piece of code to be hit, the code inside of the inner loop, this code can only be run at most k times.
Mm-hmm.
And if we are not doing it at all, we are only running the outside loop, which will just loop through it, not running the inside loop at all. But if we ever hit this if statement and go into this inside loop, we can run this as much as k times. So it's either gonna be running the outside loop. Let me write it here. So we are either if bucket size equal to 0, then no inner loop runs, or else inner loop runs, but at most k times. So we either don't run the inner loop, or the inner loop runs, but the inner loop can only run k times. So overall, it's still linear.
Exactly. Oh, just one little thing. Line 40, it should be equals 0, right? If bucket size equals 0, no inner loop runs.
Yes.
Yeah, perfect. Yeah.
I just copied it.
Yeah. I think your logic makes sense. Yeah.
Okay.
Yeah. Thanks. That's all I had. I think you did a great job on implementing all of K and K log K, and then improving to linear time complexity. Great work.
Thank you.
Yeah. Yeah. So that's all I had. So thanks for joining in, and good luck with your future interviews.
Okay. Thank you very much. Thank you for your time.
Yeah, no problem. Thank you. Have a good night. Bye bye.
You too. Bye.